I like to start these out by really just starting to talk about the market and how the technologies that we're all here learning about and we know and love, how those are applied. It should be of no surprise that as consumers in our personal lives, we're continuing to expect new personal experiences, access to data and services instantly, faster than we ever have before. It's really resulted from what we call the great digital shift. The fast digitization that has been occurring since the beginning of the global pandemic, that's continuing on today, that's really being fueled by APIs in terms of that key enabler for digital transformation. And at the same time, we're seeing growing complexity in terms of businesses having upwards of over 100 applications that they are integrating and have a need to integrate the data and services as they build out new experiences for their customers. Ultimately, that growing complexity is challenging for businesses in terms of executing and managing that with the skills that they have. And applying that, whether it's through an integration using a RESTful API interface, or whether that's using an event for asynchronous communication, or whether more traditional messaging-based integrations. And ultimately, businesses are trying to do this to delight their consumers, provide them better experiences, and ultimately drive new and more revenue through unlocking business value through APIs.
Can you stay up here because we're recording?
Sure.
And we can't see you.
Okay.
On the camera and the microphone.
I'll do my best.
Thank you very
All
much.
right. Okay. So, getting from business into technology, there is no one size fits all when it comes to solving business challenges with technology. You've got, it's resulting in APIs taking on more shapes and more sizes, whether that's REST APIs, whether that's going back even further to bringing forward some of our legacy technologies from more than a decade ago, looking at more traditional SOAP APIs for SOA interactions, or whether it's new technologies solving new challenges relative to deploying out Kafka and being able to manage and socialize those Kafka topics just like you would an API to a set of end consumers. Other technologies that you may have heard about that are continuing to evolve is GraphQL and being able to more efficiently access data and data transactions, as well as things like WebSockets, webhooks, and kind of the list goes on in terms of different APIs and types of endpoints that can apply and have many of the same challenges as REST APIs do that the API management model solves. So today we're going to use as our backdrop, I'll be going through the socialization and the developer portal experience that we provide within our API management solution, which is API Connect. We bring that all together in our integration platform called Cloud Pak for Integration that brings together many styles of integration, whether that's messaging, events, high-speed file transfer, app integration, etc. But today we'll be using as the backdrop, since it's a banking-themed event here at Apidays London. We'll be going through some of the APIs that we've published that use different technologies, and we'll show you how we socialize those and how end consumers can consume those within the developer portal experience. So let's just kind of start with the basics. When we talk about the API management model, you can see that listed here. For you that have been in this space for a long time, this may seem pretty basic. If you're new, I'll kind of go through it just to kind of start at the beginning and look at the entire life cycle and how API management helps to solve a variety of different problems and challenges that we'll go into next. But looking, starting at the left, it's being able to create and test APIs, being able to manage their life cycle, and the ability to consistently secure and socialize those APIs to a set of end consumers. So you've got the providers on the left, you've got the consumers on the right, and ultimately then being able to analyze those APIs for insights, being able to understand how to best package those APIs together into API products, and being able to understand and analyze where you may want to monetize those APIs. Again, what we're really wanting to focus on here is where we've come in the past and then where we're going in the future in terms of being able to apply the same model to different types of endpoints. Again, to be able to provide that consistency in terms of governance, socialization, and management. So we've done that today by maturing the API management model through use of first REST for, of course, popular request and response synchronous interactions that make up a majority of what we're managing within an API management solution today. And then dragging along some of the aspects like SOAP for legacy application with SOA interactions, and kind of carrying forward the past into the present, and then again looking to the future in terms of what are some of the new emerging technologies. So can anybody tell me what journey this is?
Captain Cook.
It is Captain Cook's Journey Around the World, which was nothing like a straight line. And was a long journey of fraught with perils and challenges in terms of getting from point A to point B. And API management and maturing the model that we have today really took a similar course, probably starting around 2014 or so in terms of when this market was really carved out, in terms of when Forrester and Gartner and others started reporting in the space. And the journey is one that we want to now be able to apply. Now that we're kind of at the destination of having something mature, how do we now apply that to new technologies and endpoints? Some of those include GraphQL, a number of us vendors in the vendor landscape here and of APIs and API management. If you were at the keynote yesterday, I'm sure you would have seen the visual displays of how broad and how healthy the vendor landscape is in this space. IBM, we've got great support for GraphQL built into our products. We were one of the first to get it into our products back in 2020. And of course, you're looking to apply GraphQL for a reason. Technologies are there to serve a purpose. This one's for more efficient data queries with a single call. So looking at like a banking application, looking at, say, bringing up your mobile banking experience and needing to display a list of all your accounts and all your balances on one screen. GraphQL can provide the ability to do that within a single query versus doing that within, say, a RESTful API. You'd need to take 10 accounts, you'd need 10 queries, you've got data aggregation, and it's just a lot more chatty, where there's a more efficient way of solving that problem with a GraphQL API, for example. Still needs the same ability to create it, to manage its lifecycle, and version it, to be able to secure that endpoint through a gateway and socialize it through a developer portal, just like a REST API today. And then looking at Kafka for asynchronous patterns like events. Matt's going to go into a deep dive on that here in the second half of the workshop. So I won't steal too much of his thunder in some of those use cases, but he'll go through those relative to some of our banking demo. And lastly, before we kind of get into the first part of the demo here, is really understanding the types of integration use cases and the fact that the API management model is what helps to solve a lot of those common pain points. So again, how do we take what we've solved and the pain points that we've solved for managing REST APIs and how do we apply those to new emerging technologies? How do you control access with authentication and authorization? Looking at things like rate limiting. Sometimes those can be implemented consistently for how you do rate limiting for synchronous-based communications like SOAP and REST can be done in one way, but rate limiting for something like GraphQL needs to have a lot of the same consistency with the API management model, but it also needs to have some unique aspects, where for GraphQL, it's less about the number of sequential times you access the GraphQL API. It's more important in protecting the back end by how much data and the complexity of the query that you're bringing in. So we have some unique aspects in terms of unique weighting of different fields to provide a unique rate limiting set of capability within our product set. Ultimately, whether it's API-led integration use cases or event integration use cases, or even messaging and more traditional connectivity, they all have a lot of these same problems that we're solving with the same set of technology around API management. So let's get into the demo, and we're going to try to do this live, so we'll see how the demo gods treat us today with the Wi-Fi that we've got in the room. All right. Okay, so let me see if I can zoom in just a little bit more. Hopefully for people in the back, some of these demos and screens aren't necessarily built for being seen 20, 30 feet away. But what you're seeing here is a customized developer portal experience that we provide as part of our API management solution. That's IBM API Connect. Today we're bringing this to you in terms of the what we call our Cloud Pak for integration. It is our integration platform that again brings together all different styles of integration and be able to bring those together. So the synergy between events and API management or app integration to be able to use connectors to integrate systems together. All can be deployed, managed, and used within Cloud Pak for integration, for example. Today we're mainly going to focus on the consumer end of it. So after the create, the test, the manage, and then publishing those APIs and API products to your developer portal experience for your consumers, how do they consume those? What do they look like? What types of capabilities do they consistently provide? And what types of capabilities do we need to augment that are unique to one technology or another? So here we've got Acme Bank. I'm logged in so I can control which API products are seen, which ones can be subscribed to. I'll go ahead and I'll just take a look, and we're going to kind of do a navigation of kind of different types of API products and a set of APIs. So here we have a large number of APIs. They're packaged as API products. They're versioned. I'm going to go into the customer banking 1.2 version of an API product that we have. You can see here a variety of different types of APIs that are all packaged together in a single product. You've got GraphQL here. You've got REST, that could be either OpenAPI 2 or OpenAPI 3. You've got SOAP here as well, in terms of just being able to bring together different technologies, having a consistent way to socialize those. So look, everything from discover, and then we'll get in here how to learn and try, and then subscribe, and then ultimately use that API within your application or your customer's application. So let's just kind of go into, for example, going into accounts and transactions here. And I've already subscribed to this and tied it to an application, which it makes it very easy for me to now look at the discovery and the getting started aspects of using this specific API. And there's nothing really special here that you're going to see compared to what many of us vendors and API management solutions provide in terms of dev portal capabilities. Again, we've fully customized this, we've branded it. It's all integrated in with the management and the gateway componentry. So when you subscribe, you get authentication keys. Those are pushed down to your gateway. If there's versioning that happens within the management user interface from the providers, you can automatically migrate your consumers and their subscriptions from one version to the next. And on the discover aspects here, we provide it very easy to be able to again, look at example code that you can provide for a variety of different languages, whether that's Node or Java or Python, or pick your language of choice relative to REST. When we get into asynchronous APIs and socializing Kafka topics, you'll see a different set that I'll show you in terms of a different set of languages that, that are more applicable to Kafka as a technology. But we make it really easy for you to then get examples of the request. You can try it in terms of actually trying the request and response, making it easy for an API consumer to be able to take and consume that API. Let's go ahead and we'll zoom all the way back out to that same set of products. Again, you can see this, they all have the same types of management and socialization aspects in terms of the ability to use forums and blogs and rate them and discuss them and have PDF documentation about them, all the things that as a consumer you would want to have. Let's go ahead and look at one, account transactions, for example. This one happens to be socializing and managing a Kafka topic using asynchronous API technology. Now here, you can see a set of operations. And here you can see, in terms of the consumption, a different set of, you've got Kafka JS, you've got Kafka Python, you've got, of course, Java and a variety of languages that you can see and instantly access different code snippets that you can then use within your application to drive this API usage. This is all consistent with what you get, and we're just reusing that. So many of the aspects that we're reusing within REST, within the API management model, is the same, but then we augment that with payload schema examples that are specific to Kafka topics themselves. So with that, I'm going to pause and I'm going to pass it over to Matt. I don't want to get into too much more detail on the event aspects of socialization here. Let Matt start to deep dive into events and the intersection point between events and API management. From current slide. And there you go.
Okay, thank you very much. I'm also a bit of a wandering presenter, so I'm going to try and keep myself founded in the middle here. So I want to talk a little bit about event integration to start with, and the value of events and the increasing importance of events that we're seeing across all types of businesses. And then I'll sort of talk about why that relates to what we're talking about here, which is the ability to manage and govern those events in a sort of a similar way to the way that Nate was describing there. So why are people using events, and why is events like emerging? I mean, business events have been around for quite a long time, but I would say the emergence of things like Kafka as a technology and really trying to support that digital transformation that Nate was mentioning at the beginning has reinvigorated thoughts around events. Events telling you what's happening in different parts of your business. What's happening with your customers, how they're interacting with you, what's happening with your assets, your inventory, your interaction with partners, your value chain, and so on. So there's been a big focus on events telling you how your business is performing, but also enabling sort of responsive, engaging experience with end consumers. And that's kind of what this slide is talking to. So, when we started to provide more facilities to end consumers to access aspects of, their business with a particular company. It was a lot about providing apps, for example, that allowed you to request information. So if it's your mobile banking app, it's requesting your balance, it's browsing products and maybe making an online application through the app. All of those sorts of things, very well suited to APIs. APIs have been supporting that kind of interaction, and really there the user is engaging the app to do that. But the other side to that coin is when you want to engage the user proactively, and that's more in the space of things that might be going on with that customer's information that a business holds they're not yet aware of, and you want to tell them about it. So it might be there's this account activity happened, and I'm going to send you a notification that's there. And you might think, well, that's fine, I knew that, I just made that payment. Or you might think, oh, hang on a minute, that's not something I'm aware of, and I might do something. So the ability to have that engagement, both in terms of what you're requesting of your bank or your favourite retailer or whatever environment you're in, versus how they engage with you is kind of helping that experience. And events really play a role, particularly in that second part. So if we dig into a couple of examples on those two. So the top one here is the user engaging the app, so balance inquiry. So if I want to find out what my bank balance is, I'll go onto my mobile banking app and I'll make a request. That will be served up via an API, and I'll find out what that balance is. Actually, events are playing a role in that space as well, because I think when that facility emerged to consumers, I don't think people realised how much it would get used. You know, who here checks their bank balance on their mobile app at least once a day? Okay, a few hands. It's a facility, it's there, it's the sort of thing that you might check in the morning, or if you're just about to make a purchase. And I think the fact that it's happened so often causes, you know, more workload than was anticipated maybe on back-end systems. So even there's a thought around, well, maybe for balance inquiries we need a local copy. We need something that's cached that for that particular inquiry doesn't necessarily need to be right this minute. Maybe a local cache is good enough, and we can feed that with change events. So if there are transactions, we can use a change data capture technology, and we can feed that into a local copy. And actually, I was struck when Sarah was talking earlier about green software. There's a thought there about like when you'd want to do that. That might be a way of doing things more efficiently. It might be a way of saving compute on the back end when it's not actually needed for a particular use case. So APIs absolutely, when you absolutely need to know what the balance is, you're just about to make a transaction. But a casual inquiry on an end consumer mobile banking app, maybe I can use a local copy and I can feed that with events. Then you've got the second type of activity, which is that notification. So as I say, like account activity, something's happened, a transaction may have happened, maybe that's flowing over a transaction processing system on your mainframe or your servers, and we would like the end consumer to be aware of that. So we can take an event from that happening, we can feed that out through to their mobile application experience and create them a notification. So real-time events using things like Kafka are really accelerating. We're talking to a lot of different types of companies as IBM about what they're doing with events, and really it's kind of, you know, this virtuous circle of being able to detect business events as they're occurring, do some maybe real-time insights, some dashboarding around them, and maybe getting to the point of being able to derive some situations from them. What's actually going on in the business? Maybe it's that event, maybe I process that event slightly to get a particular view on it, maybe I combine it with other events, and then I can feed that back into what actions I might want to take. And these are actually retail examples, so I apologise, they're not financial ones, but you can kind of see the sorts of things that might be useful to know when you, say, have things about stock movement or inventory, where you can actually have live inventories updating, feeding into things like fulfillment and deliveries for customers. Can you do rolling stock checks? Can you get real-time feedback from in-store collection, for example? So a whole bunch of use cases that you would see. But the point I'd make here is they're not all using unique streams of events. They're all reusing the same streams of events in different ways. So use of real-time events is accelerating, yes, but it's also about combining those events, reusing those events, and so on. And that really plays into the thought about socialization discovery, because what you don't want to happen is a load of duplication where each project is saying, well, I need to source this event, let's have some integration there, let's create a stream of Kafka events for that, when another line of business has already done that, already put that investment work in. You're just duplicating what you have. So back to the Captain Cook journey from earlier. This is a journey we've seen before with APIs. There's a whole set of pain points that are emerging around use of Kafka and events that are exactly the same pain points in a lot of cases as APIs have gone through. So it's, if I've got a lot of streams of events, Kafka events happening, how do I control access to that? Some of them might be quite sensitive. Do I need to ensure that only particular lines of business with a need to know can use those events? What do I do about managing workloads when those 20,000 queries come in through my account query API, and I'm not sure that my backend systems can handle that? How do I handle that if that's if that's events? How do I have agile development, which is really key, because I think a lot of times people think, well, if you apply all this management and governance, that becomes like a very centralized service, it slows everyone down, everybody then has to go to a single point of failure, a bottleneck. And the way API management is structured, and the things Nate was showing earlier around the synchronous API space, is it's around self-service. It's about the ability to discover, to register your access. Yes, have some review workflows in some cases, but actually be able to make use of those events without having to go to a central service. And then duplication, reuse, and breaking changes. So I think this is a great slide. I think it applies equally to events. And the Captain Cook part of it is, we can go straight there. We've got the map now. We discovered all the countries along the way. We know what's needed in a way that we didn't when we started back in 2014 and we had that journey to discover these things. So we can get there a lot quicker. Okay, so in terms of capabilities then, what does this boil down to? So Nate mentioned that we've got an integration platform called Cloud Pak for Integration. Part of that is an API management solution for events. And you can use that as an event-specific solution, or you can combine that, as we showed in the demo, where you've got APIs and events being managed together. Because sometimes you might want a synchronous API, sometimes you might want GraphQL, sometimes you might want Kafka. And for something like account transactions, you might need to use a combination of those things depending on what you're trying to do. So it's really providing that common management facility and borrowing some of the concepts and applying them to events. So we do have this same standardized way of describing events with something called Async API, which I'll talk a little bit more about in a minute. But that's really like a sister project to Open API and is trying to standardize how we describe events and their schemas and their payloads and everything in the same way as we have APIs. And we're really trying to apply a lot of the other characteristics to enable that discovery, socialization, reuse, but also control. So I've got 4 Ds. Always good to have a hook to remember a session. So the 4 Ds of API management for events. So first one is describing the events. So this is kind of like a dual one. It's a technical description. So if I'm using a Kafka topic and I'm coming in as a developer, I need some way of capturing, okay, where's the broker live this Kafka topic's on? Where's the endpoint? If I'm sharing it, what port does the application need to communicate with? So all that technical detail, and also the schema. So what would be a well-formed event that I could expect to receive or maybe pass through as someone who's socializing it? And it's something, that aspect is something that is starting to be more supported by tooling, because part of the value of having this async API document, for example, is that you can then feed that into code generation tools, into validation tools, and you can make it much easier for developers to build applications to consume them. But you also need a level of non-technical description. So you'll have seen in the demo, we made a brief attempt to describe some of the business value of what those particular streams were representing, because you need someone who's discovering that to be able to work out, is this the right stream for what I'm trying to do? And yes, you can provide some contact details. So if you're not quite sure, you can contact the owner of that Kafka topic. But generally, you would want enough information on there so that people could self-select that, so you don't become a bottleneck in that way. So a bit of technical description, which is within the async API document. That includes things like the schemas and also a bit of business description of what you're getting. Okay, so that's description. What about discovery? So this is the sort of bread and butter of the portals that Nate was showing earlier. So you want an ability to go searching as a developer. So you might be doing a search on a particular business object, or a bit of a fuzzy search to see what types of things might be available. You want to then go and look in your catalogue, see what people have created and provided, particularly if you think something new might be required. So you can make sure that before you then go and commission some new IT, get some new topics created, that you're not reinventing the wheel. It's not something you can use already. So it's catalogued, it's searchable, and you can consume it with those self-service sign-ups and so on. So that discovery part, important. Oh, seem to be going the wrong way. Sorry about that. So I already talked about bottlenecks and a fear that there's a central team that stifles innovation. So decentralizing that access is unlocking that innovation that can happen if you have that ability to self-serve access. But along with that, you kind of want some controls. You want to be able to say, this sort of person should be able to access this, or I can manage this sort of workload, and I can track who's using it. So part of the solution is about being able to apply policies. And in our set of capabilities around products, and Nate was showing an example of a product earlier that had some Kafka topics, it had some REST endpoints and so on, you can apply policies consistently across these. So you can say, I can group these together, and I can say who should be able to access them, what should happen if someone asks to access them, these sorts of things. So a system set up to track use, to be able to provide those kind of control points and proxying of endpoints through our gateway technology as well. And then the final D is decoupled systems, which is kind of interface 101 to some extent. It's the ability to define an interface that you can then have people using, but not having it hardwired to how you implement that in the back. Because what you don't want to happen is have to make changes, then you break someone. So there's a whole piece around the fact that you've abstracted through an interface, in this case an async API interface, and you can change the implementation to some extent. And if you do need to make a breaking change to that, you can then version it. You can say, I'm going to issue a new version. And so people are aware who are consuming that this is version 2, I might need to do something different, I might need to adapt to that, but you're not breaking the version 1 consumer. And the way that we sort of also provide additional decoupling is through an events gateway. So the ability when you look up an endpoint, not to be connecting directly to that back-end Kafka topic, for example, but to be going through a gateway service, which proxies where you're going, so it's performing that routing, but it's also applying the policies so that you can then change that without, again, affecting that back-end. Okay, so this is a bit of a summary of what I've talked through so far. So it's within the what we call event endpoint management as part of IBM's integration portfolio. We've got this capability to allow you to manage both REST APIs and GraphQL and all the other synchronous types of APIs, along with Kafka topics in the same user experience. We've got that discovery piece, the developer portal, the API manager you'd expect that we would have for APIs. And you've got that security aspect. So we have this event gateway service, and it can apply those policies, and actually applies them directly at the Kafka protocol level. So something I haven't mentioned yet, but probably should at this point, is this isn't a IBM facility to manage IBM's Kafka implementation. It's intended to be something that is able to work with anything that speaks the Kafka protocol. So if you're using IBM solution, open source Kafka, maybe you're using Confluent platform, you might be using other Kafka API compliant technologies like Red Panda or Pulsar. All of those things will work with this because there's a lot of standardization around the API protocol for Kafka, and so the solution we've built is encompassing all of those different options. Okay, so back into the demo. So this is where I work out if I can figure out how to use Nate's laptop. Is this still zoomed in? Am I still logged in?
Yeah, it should. We'll just maximize that there.
Yep.
And
Yeah,
I'm
okay.
not sure where you want to go.
Well, I'll start here because I'm here already. So we already had a quick look at this one. So here we go. So we've got the common the common way of understanding what this is. So some of those technical aspects, as Nate mentioned earlier, quite important if you're working with events. Understand the event format, what you would receive and what you would then be able to do with it. So you can work out whether you're injecting an event, you might be publishing something, or you might be subscribing to something else, what you need to be able to handle, and what, if you applied validation at the Kafka level, would be rejected as something that is not conforming to that particular topic schema. And as Nate mentioned earlier, a whole bunch of embedded options for getting code snippets, pulling in the dependencies, and also, as I mentioned earlier as well, the ability to, at the bottom here, actually download the schema and the async API document if you're using some other tooling that would you would then generate your applications from. So in terms of like the back end for something like this, quite often what you'll find is the transactions that you might be wanting to emit events over are coming from your transaction processing system. So, you know, it might be Kix or IMS or something in terms of running on your servers or your mainframes that's actually processing those transactions. Quite often, things like MQ is used in the industry to communicate and coordinate those transactions with other updates. And one thing you can do with MQ is you can tap into that to create a stream for a Kafka topic. So there's something called streaming queues, which is a fairly new capability of IBM MQ, which means that if you've got an existing queue that's sitting between two applications managing a transaction, you can configure that to be a streaming queue, and that would create a second copy of the MQ message and send that through a Kafka connector into a Kafka environment. So it's quite a common way of being able to create a stream of events without disrupting what MQ and the transaction processing is doing on the back end. So that's the sort of thing that might be backing this particular async API. So if I go back to the beginning, I'll find another one. So I think we need the customer accounts.
I think it's create account.
The create account? Well, I was going to look for the address change data. So is that in the customer accounts here? Let's see if it's this.
It might be in that one. You might be right.
Oh no, I'm back. Sorry, I'm back where I was. Try this one. Should have grouped my accounts better. That's GraphQL. Okay, well I'll talk through it in any case. So if I wanted to say get notifications from customer address changes, so I want an event to be emitted every time a customer address is changed because I want to then consume that in an application, maybe drive some other processing, or I want to make an offer based on the fact the customer's just moved. That might be something I want to use Kafka for. And typically that information might be in a back-end database somewhere, that change. So another use of Kafka might be a CDC use case where I have a Debezium connector that would look for those change data capture events and would create Kafka events from that. And so in the demo, within our screens here, we had an example of that where you could actually detect that change and feed that through as a stream of events, and the back end of that would be that CDC use case. Okay. So I think with that, I'll turn it back to Nate, and we'll have a bit of a wrap up.
All right. All right, so we'll just wrap up with a couple of different topics, just making you aware of some of the ways that you can consume API management along with events and being able to have that expansion of the API management model to events and Kafka topics. We provide that with choice and flexibility. We have, again, our Cloud Pak for Integration, which is our integration platform, bringing together those sets of integration capabilities. We also offer our IBM API Connect software product by itself outside of the full integration platform that can be run just about anywhere. And then, of course, for those who don't want to manage software anymore and are looking for software as a service, we have multiple offerings there as well, based on isolation and availability requirements that you may have. We're here to help you. We'll be here the rest of the day. You can come chat with us after the session here, as well as at booth number 1 upstairs. And leaving you with some specific thought leadership and technical assets that can help you on your path, no matter what vendor you're choosing. But we'd certainly like to be that for you as well. So you'll be able to get access to the slides as well as the recording and all of the links that will be provided here as well. You could certainly try everything that you've seen here today in terms of the integration platform. You can try that for free in terms of getting that deployed in an as-a-service manner and being able to try that out. We also have API Connect, which is hosted on, as a service hosted on AWS, that you can also get a free trial on, and within a minute you can get an instance of the full product and do everything from creation to management, socialization, publishing, all within one single experience and all delivered as a service. So you can try out our version 10 user experience and give it a whirl. So with that, I'd like to say thank you to everybody who's shown up today, and great to again be here in person with all of you, getting us back to events in person versus watching them on YouTube. So thanks, and we'll be around for questions afterwards.
Yeah, I mean, if there's any questions in the room now, we can take them. We've got time, I think. Any questions from anyone? Anything around like use of Kafka or on the REST API side?
I'm very new to events. So how do you make sure when you're not getting notified is generally everything is going well, or maybe just Kafka is down, just like connectivity issues?
So Kafka has various facilities to monitor the environment and whether the Kafka environment itself is healthy. And you can also set up a number of different brokers, so you've got high availability and you can make sure you've got a more resilient environment. IBM Event Streams, which is IBM's Kafka implementation, has a specific management UI, which gives you dashboarding in terms of the system health and those sorts of things. But there's a lot of things being built around the Kafka ecosystem around making sure that
dashboard is holy, or it's getting another event?
it's consuming its own events. so it's it's drinking its own champagne, as we say, in terms of the fact that the Kafka brokers themselves are emitting events to say, yeah, I'm alive, and then the dashboards can consume that. Is there a question up there? Right?
We're already using Apache Kafka in our different applications to do the integration with different applications. So one of the challenges which we face is, for example, some order management system in there, which they cannot produce an event. They can only consume REST APIs. Okay, and we cannot directly expose our event to those guys. So what we have to do is we have to write a REST layer on top of our event so that they can call our REST APIs, and then internally we'll convert those REST data to an event, right? So does your Connect API platform, does this provide any facility where you can expose that as an API, but internally convert it to an event?
Yeah, so I think you can
repeat the question.
Yeah, sorry. So the question was really around how I believe like how you access events from and wrapper those events in terms of like a REST API. You can certainly do that, and in terms of like getting events from different places, I mentioned like an MQ connector at one point and a Debezium connector. There's a whole suite of Kafka Connect connectors to actually source events from different places. So hopefully you don't have to do so much custom work around like extracting events, but then once you've got a Kafka endpoint, for example, you could wrapper that as the implementation of a REST API to get latest state, for example. So there's definitely facilities to do that.
or just specifically using an async API, and then socializing that
Yeah.
in a developer portal experience versus giving them direct access, which then you don't control, right? You don't have the ability, if you don't have the socialization and the management aspects to be able to do subscriptions with authentication, then you're in control of understanding who is using that, as well as being able to take that subscription away if you end up having changes in your organization, or you find out you've got specific threat actors who have subscribed to them. You can actually take those subscriptions away, and then of course your access control point being your event gateway, and that proxy to the back end topic would be that control point.
Yeah, and what I've found is it gets to an inflection point with companies that do like first 2, 3, 5 Kafka projects, and they start getting people coming to them saying, oh, I really need your events for scheduling or for accounts or whatever. And so they give one team access, then they give another team access, or they have to do some custom integration. And there's a pain point threshold that then like that scaling problem really hits. And that's where something like this comes in, having a much more structured way of being able to advertise these things, but still have that level of control.
And that's what we're seeing regularly with a lot of our enterprise customers in terms of saying they're deploying out a lot of Kafka servers. They've got a lot of events and Kafka topics that are created, but they're not necessarily getting the reuse. And so they're creating new, every organization just continues to create more and more Kafka servers, and versus in many cases it's very similar or the exact same thing they're trying to accomplish. Whereas bringing in a model like this allows you to then get that socialization and that reuse in a consistent and governed way. So just like you were saying, there's like that inflection point of you kind of have the Wild West and just let people use things, and then eventually it comes to a point that's no longer sustainable anymore. Yeah. So hopefully this type of technology and applying the API management model to events will help to solve those problems.
Yeah, so when you talk about events, you'll be talking mostly about Kafka. Does async API or your tools also work with MQTT and other event systems?
Yeah, so there are, when I said like Kafka equals events, it's like obviously there's a big push around Kafka at the moment, but there's MQTT, there's MQ itself, which has some pub/sub capabilities. There's events from different places, and certainly like looking at the number of protocols we can support, we've kind of started at the Kafka end because that's where the sort of the bow wave of sort of interest and some of these big problems have been emerging around management. So started there, but certainly looking at other protocols in terms of how could you take MQTT endpoints, or you could take MQ endpoints and represent those in the same way, so you could have the same ability to discover and manage those. And then there's a thought about, well, we need some way of employing different policies, because, for example, what you might do to manage workloads in MQTT might be different from what you do in Kafka, might be different from what you do in MQ. So there's definitely a thought in terms of how we evolve this, about multi-protocol support, how we cater for other styles that are contributing in the event space.
Using Kafka for an event-driven architecture with multiple REST APIs, do you think it's a very resilient solution, or is it? How do you make it more resilient and less like if any infra goes down or anything happens, there are chances of losing events, and then you have retry mechanism, and then we have all the fallback options, which are not very efficient way of dealing with event-based event-driven architecture. So how do we balance that? I mean, when should we kind of use it, and when should we not prescribe this kind of event-based?
Okay, so the question was around firstly resilience of Kafka environments and how much sort of, in a way, quality of service you can expect from the events that go through that, and when should you use that versus maybe using other technologies. So in terms of Kafka itself, there's, as I mentioned earlier, there's different ways you can make it more resilient. I mean, Kafka works with a data replication solution across multiple brokers with a quorum solution. So the idea is you would start with a minimum of 3 brokers, and you can have 5, you can have 7, you can scale that out so that you can survive a number of brokers going down, but still have that that consistency, that replication. You also mentioned like there's different options within Kafka to say, well, I would like all brokers to acknowledge that a message is like an event has arrived before I then continue, versus a more sort of, I'm going to fire these out there, and if they get there, fine. It really depends on the use case and what you're trying to achieve. There are use cases where I absolutely wouldn't use Kafka. So I come from an MQ background, so I worked in MQ for 4 years before I worked here, so I've had both sides of this. If you want something as like assured once-and-once-only delivery, where you don't want to put it on the applications or the Kafka infrastructure to say, I need to make sure it's not at least once or at most once, and having to deal with duplicates and so on. MQ as a technology is a very good fit for that. It's been designed for that. So I certainly don't recommend like using Kafka in those situations. So it's very much, Kafka's got resilience capabilities. It's very well suited for these kind of publish, subscribe, mass scaling use cases. But it's not the answer for every use case. And there's definitely still a place for things like queuing and assured delivery when your use cases need that. Okay. Any more questions? All right. Well, as Nate said, please do catch us in the solution space if you've got any further questions. Thank you very much.
Thanks, everybody. Have a great rest of the conference here today.
Yeah.